All right, this problem is telling us that we have a quadrilateral PQRS with specific diagonals PR and QS. I'm going to draw that quadrilateral before I even begin. And I'm going to label it P, Q, R, and S. Then I'm going to draw on the diagonals that they told me, PR and QS, and they intersect at point T. All right, we're going to add one by one the information to the diagram to determine if it is a specific kind of quadrilateral, specifically to see if it is a rhombus, a rectangle, or just your plain old parallelogram. All right, first they tell us that PS and QR are parallel, and PS and QR are congruent. This makes it a parallelogram, because in a parallelogram, at least one pair of opposite sides are congruent and parallel. All right, I'm going to erase this information before we move on to do our next problem. Problem B tells us immediately that this is a parallelogram, which means I can make both pairs now of opposite sides parallel and congruent if I wanted to. It also tells me that PR is perpendicular to QS, meaning they intersect at a right angle. Specifically, rhombuses are parallelograms whose diagonals are perpendicular. So this would make PQRS specifically a rhombus. All right, I'm going to erase that right angle, move on to the next one. They tell me it is a parallelogram still, so I'm going to leave my opposite sides parallel. And now I'm going to mark that PR, the diagonal, and QS are actually now congruent. It's hard to mark that the diagonals are congruent, but basically this diagonal is congruent to this diagonal. Specifically in a rectangle, we have a parallelogram whose diagonals are congruent. This would make PQRS a rectangle. Finally, let's erase all of our markings. And now we're looking at PQRS again, and we know that only QP and RS are parallel. Only this pair of sides is parallel. If we only know that one pair of sides is parallel, it can't be a parallelogram. So it has to be a trapezoid. So technically, the answer to our question would be none of these.